Two players are playing table tennis. Player A hits a ball at a height of 0.24 meters above the edge of the table. The initial speed of the ball is 12 meters per second. It is horizontal. The ball bounces and then reaches a peak height of 0.18 meters above the table with a horizontal speed of 10.5. We need to figure out the kinetic energy of the ball immediately after the bounce. So now the question is saying the ball bounces and then reaches a peak height of 0.18 meters. So let us complete the diagram. After the bounce, let's say the ball reaches this point. So imagine this is the highest point of the ball after the bounce. It is saying that the peak height is 0.18 meters. So let us label that. The height of the point above the ground is 0.18 meters. And then they say the horizontal speed of 10.5 meters per second. So the ball bounces, and at the peak height, the velocity, the horizontal speed is 10.5 meters per second. Now we already know whenever the ball is at the maximum point, the y component of the velocity is always zero. The velocity is completely horizontal. And that is why at that point, if I draw a tangent, that tangent will be completely horizontal. And that velocity is given to us as 10.5 meters per second. Now the question is, find the kinetic energy of the ball immediately after the bounce. Now, some students make this mistake. So, kinetic energy is, of course, half mv square, right? But the speed, you cannot take the speed as 10.5 because 10.5 is the velocity at the peak height. And the question is asking us to find the kinetic energy immediately after the bounce. So, immediately after the bounce, which is this point, if I draw a tangent at this point, that will give the direction of velocity. So let's say this is the direction of the tangent. This velocity is the velocity immediately after this bounce. And this is the v which we need in the formula half mv square. Now, there are two ways to solve this question. Method one is using the law of energy conservation, which is faster and simpler. So, first we will understand that, and then we have method two, which is using the CWAT equation. So, if a student doesn't know energy conservation at this point, he or she can stick to the method two. So, here we go. Let's start with method one, which is energy conservation. So, now if I label the 2 points, so this point, which is the bounce point, let us label this as point A. And at the highest point, let's call that point as B. So according to the law of energy conservation, the total energy at A should be equal to the total energy at B. So let us write EA, total energy at A, is equal to total energy at B. But total energy is a combination of kinetic energy as well as potential energy. So we will write that for point B as well. So this is called the law of mechanical energy conservation. So mechanical energy, if you remember, that's a sum of kinetic energy as well as potential energy. So this is kinetic energy at B. All right, going back to the diagram, at the point A, the velocity is V. So we are supposed to find the kinetic energy. So let us take KEA as it is, kinetic energy at A, plus what is the potential energy at A? We know the formula of potential energy is mgh, but the point A is on the ground, so we will take height as 0. So potential energy at the point A will be equal to 0. Now coming to the maximum height, the peak height, point B. What is the velocity? 10.5. So we can use half mv square, half m into 10.5 squared, plus B was having a height of 0.18 meters. That is the height h. So we can use mgh. So let's write down mg into the height was 0.18 meters. The mass of the ball is 2.7 grams. So it is important for us to convert that into kilograms. So let's write down the final expression. Kinetic energy at the point A will be equal to, on the right hand side, we'll write half. Mass is 2.7 grams. So we will convert that into kilograms, multiplied by 10.5 squared plus mgh. So again 2.7 into 10 to the power minus 3. G is 9.8 and the height is 0.18 meters. And if you solve all of this, we will get the final answer for kinetic energy at the point A as approximately 0.15 joules. So let us repeat what we have done. We have used the law of energy conservation for point A and point B. Now, since the question was a two marker, that is why I started with method one, because this is the fastest and the easiest way to solve this question. Now, let's say if a student doesn't know the law of energy conservation at this point, this question is still solvable using the CUAT equation. So, how do we do that? Back to the question, we were supposed to find the kinetic energy of the ball immediately after the bounce, which means this tangent which we had drawn earlier, this velocity, if we can figure out, so then we will do half mv square. So how do we find this velocity using CUAT equation? Step one, let us break the velocity v into two components, the horizontal as well as the y component. So let's say if I draw a horizontal line, this will be the x component of the velocity, and then let's say this is Vy, this will be the y component of velocity. So our job is to find Vx and Vy, and then we will use the Pythagoras theorem to find out the velocity. Now, if you recall in the projectile motion questions, whenever the air resistance is negligible. So see, in the question itself, they have said air resistance is negligible. So whenever air effects are to be discarded, then the horizontal component of velocity always stays the same. So this 10.5 will always stay the same in the entire trajectory. So immediately after the bounce, all the way till this point B, and even afterwards, the horizontal component will never change. So Vx we can write as 10.5 meters per second. So at the bottom, let me write. So the velocity is V. The x component of velocity will still stay the same 10.5 meters per second. Now our job is to figure out the y component of velocity Vy. So we will be using any of the other CUAT equations. So let's see which equation will help us. So Vy is the initial velocity. We have the distance. So let us use the third equation, v square is equal to u square plus 2as, but along the y-axis. So let's write down. The equation is v square is equal to u square plus 2as, but since we are supposed to apply that along the y-axis, we will use these suffixes. Now going back to the diagram, at the point A, which is immediately after the bounce, the velocity was Vy, the y component. At the point B, when the velocity was completely horizontal, we will say that the y component of the velocity at the highest point is 0. And why is it 0? That's a concept, if you recall, whenever a velocity is completely horizontal, its y component will be 0. And vice versa as well. Example, if a velocity is completely vertical, then its x component will be 0. So in this case, at the highest point B, velocity was completely horizontal, so the y component is 0. So Vy we will take as 0 at the highest point. So let's write that down. So final velocity we will take as 0. Initial velocity we are supposed to find. And incidentally, in this question, initial velocity is Vy only. So let us write Vy instead of Uy. We'll write Vy square plus 2. Acceleration along the y-axis is negative 9.8. And the distance, if I go back to the diagram, this is your SY, displacement along the y direction, which is 0.18 meters. So we'll write 0.18. And now if we simplify this, we will get Vy squared as 3.528. Now there is no need to square root this expression. There is a reason, because we are supposed to find the overall velocity V. And how do we do that? Using the Pythagoras theorem. So we will write V is equal to square root of Vx square plus Vy square. Vx value we already have, which is 10.5 squared, and the Vy square we can directly write as 3.528. So 3.528. And now if we simplify the square root, we will get the value of V is 10.66 meters per second. That is the final velocity immediately after the bounce. Now the question was to find the kinetic energy of the ball immediately after the bounce. So we will use half mv square. So let us write down half. Mass of the ball is 2.7 grams. So we convert that into kgs, and the velocity was 10.66 squared. So if you simplify this, again, we will get approximately 0.15 joules as the answer. So this was the method 2 using the CUAT equation. But method number 1 was easier one, and it was the faster one, which used the law of energy conservation. So either way works, but please prefer the method 1, because in the CUAT equation, we will have to deal with different components, which is a hassle.